find the intercepts of f of x equals, and we see in parentheses here 2x plus 1 times in parentheses x plus 4 times, and in parentheses x minus 4. Right, so this is a polynomial, but we call this the so-called factored form, and this is actually pretty good. Okay, having the factored form is actually a lot nicer. So why? Okay. Because the factors actually give us the x-intercepts. Okay, we know this first of all. Okay, how many factors are there here? There's 3 factors, right? So there's 3 factors. So we could conclude that this is actually going to be a 3rd degree polynomial, right? So that's good. So how do we find the x-intercepts? We just set each factor equal to 0. Let's set 2x plus 1 equal to 0. We'll set x plus 4 equal to 0. And we'll set x minus 4 equal to 0. So let's take a look, right? Okay, let's subtract the 1. So we get 2x equals negative 1. And then x equals negative 1/2. So what can we conclude? We can conclude that negative 1/2 is an x-intercept, right? Here we'll subtract 4. We get x equals negative 4. So we can conclude that negative 4 is an x-intercept. Here we'll add the 4 to both sides. So we get x equals positive 4. Okay? Notice that there are 3 x-intercepts here. Okay? Now to find the y-intercept, we just actually have to plug in 0 here, right? We're going to plug in 0 into each instance of x here, right? Everywhere we see an x, right, we're going to plug into 0 and see what we get. Okay, now I'm just going to sort of do this here, plug into 0, 2 times 0, right? So we get 1 times 4 times negative 4. That gives us negative 16, right? So we're only going to have one y-intercept. Okay. All right, so these are the 3 x-intercepts, and here is our y-intercept here. Now, the problem does not say to graph this, but we can graph this. Okay, it's just going to be a rough little sketch. Okay. So what can we conclude here, right? Well, okay, I know where my x-intercepts are, right? At negative 1/2, at positive 4, and negative 4. I know that I'm going to have a y-intercept at negative 16. I'm just going to eyeball this one here, negative 16, right? But the key is, okay, what's the graph doing? And what we want to do is we want to determine the end behavior. Okay. Now let's think about this carefully. Okay. We know that this is a 3rd degree polynomial, which means it's odd, and the leading term is positive, right? We know it's positive because, well, we don't see a negative sign here anyway, right? Let's think about that. If we know that this is an odd polynomial that is positive, we're going to have I'm not going to say your usual S shape, right, but a basic S shape, which means we're going to go down to the left, up and to the right. We know that these are the x-intercepts, right? The graph must touch, okay, at these 3 points. So in this case, we're going to have something that looks like this. We're going to touch that guy, right? We know this is our y-intercept, so we're going to touch that. And then we should look a little something like this. Now, once again, this is just a rough sketch, okay? I'm not saying this is the exact sketch. But the key is, you should have the correct end behavior, which means we go up, down, and to the left, and up and to the right. And you should have the correct x-intercepts.